Paul McWhorter has a series of lessons on the Raspberry Pi Pico W. In lesson 31, he demonstrated how to retrieve weather data from an internet weather site, download the data, look at the information provided, and put it in a form that might be readable to the user. For a homework assignment, he asked us to, in addition to what he did, to display that information on something like an OLED display, and possibly even adding an RGB LED to get some indication on what was going on. Now in this video, I'm not doing the RGB LED, but I have added the OLED display. One problem I had is that the refresh rates on the camera and the refresh rate on the LED display causes some interference patterns. So instead of showing them live, I took a still picture of the screens that were written to, and I have them shown in this video. Let's look at the code that I have to accomplish the assignment. In addition to what he provided in the lesson, I had to do some setup for the display. So on the line 1, I had to add the I2C library, which is called I2C. And the driver is SSD 1306, so I had to import that library. For the log on to the Wi-Fi, it's the same as I had in the previous video. Now we had to set up an object for the display. I called it I2C with I and C in lowercase letters. I showed that the width and height in pixels is 128 by 64. And then I set up another object of display using the library and giving it the width, height, and the object name. Then I have code that we've gone through in the lesson and in previous videos on logging on. Now let's look at what happens after that. I have on line 45 a while true loop that runs forever unless something interrupts it, like a keyboard stop or a lack of power or a failure with a router or something of that sort. So one of the things that's provided by the site is something called DT. So I set up a value here called old DT, and I set it to 0. Now DT is given in seconds from January 1st at midnight of 1970. So I set it to 0, so we will never see a legitimate reading of 0. And I set up I equal to 0 as a counter. So in the while true loop, I look first to see if it's connected already. If not, I go out and connect to the Wi-Fi. And I print a statement here just to show what's going on. You know, two lines below that, I go out and get the information from the website, and this line shows where to go for that website, and that was covered in Paul's tutorial, except that I had to change the city where I am instead of the city where Paul is. So I'm in Huntsville, Alabama in the US, and following that is the APPID key And of course, that's also different than Paul's. You get that when you set up an account on openweathermap.org. Now, following that, I look to see if the date and time, whether or not it's equal to the old date and time. If it is, I don't execute this code before it. I go down, way down here to line 116 where I just start displaying stuff to the screen. But now let's go through what we do if we do get a new reading. Now I notice in this print statement up here, I print the value of I, and then I bump it. So we may read this site several times before we get a change. It turns out that the date and time reported is not the local current time, but the time that the site last got an update. So if it's new data, I reset my counter and I print what it returned. Now let's take a look at what kind of data. This is the data that's returned. And one of the things you might notice here is the time zone is minus 1800. Well, it turns out that the date and time return is the date and time for Greenwich Mean Time. And to get the local date and time, we have to modify what they provided by the value in the time zone. Since the date and time is also in seconds, if you look down below in line 62, you'll see that I read the date and time and then I add the time zone. Now for this location, the time zone is a negative number. So we are earlier than Greenwich time. And then I print what the date and time is. Now above that, where I got the time zone, I called that time zone in seconds. And just for information, I calculated what the time zone in hours would be. And it turns out you divide the number of seconds by 3600, and that tells you how many hours you are from Greenwich Mean Time. So now let's start looking at some of the other code. Because of the how many characters I can get on a line of the display, I want to display the year as a 2-digit number. So I subtract 2000 from the year that's provided when I did this conversion to local time up here. So I should get a 23. And then the month is index number 1 of the DT array. The day is index number 2. And then I create a string of the date. And we're using month, day, year format here. So I have the string of the month and a slash. And for the second entry, I format this so that we always have 2 digits, even though the day may be something less than 10. So we have the day, slash, and then the year. So the other problem we have on the time is world time is a 24-hour clock. And in addition to it being a 24-hour clock, and we're used to a 12-hour clock, at midnight, they call that 0 hour. So we have a problem at midnight because we call midnight 12 o'clock. So I set up this little routine here to determine what the time is as a 12-hour clock. So I look to see if the hour is 0, we know it's midnight, so we make it 12. If it's a number that's greater than 12, I subtract 12 from it, and I set the AM PM value to PM. You know, if I fail this this if statement, I set it to AM previously, so it'll stay AM. Then I go through something to set up a time string. I have the string for the hours, for the minutes, and I format it as a 2-digit number, and then I add in the AM PM value. Then I have a print statement that just prints out the date, a space, and a time. And if we look at this data down below in the shell, you'll notice that the last reading was made on 8/27/23 at 2:27 p.m. Now, other information that's provided by the website is what the sunrise time is and what the sunset time is. So we have, we know that sunrise is always at this latitude in the morning. So I don't have to go through any calculation. I know it's going to be AM. So I have a string set up that says sunrise, and then the sunrise hour and the sunrise minutes as a 2-digit number. For sunset is always PM, but we want to convert that to a 12-hour clock. So we look to see if it's greater than 12. If it is, we subtract 12, and then we set up a string for the sunset time. And if you look at the data down in the shell, you notice the sunrise here is at 6:15 in the morning, and sunset is 7:15 in the evening. Additional information provided, of course, if you look at the data return, here it says we're in Huntsville, and I know I'm in Huntsville, Alabama. So I've set that up. And then in the shell, I print the location. And the temperature, in our line, when we accessed the map, we said we wanted imperial units. So I get the temperature information from the data provided. And if we look at that data, let's see, where do I see that? Right here. The last temperature today, when I was recording this, is 96.61, and it's 0 degrees Fahrenheit. The humidity, dig down into the data, as we did with the temperature, and we print that out as a percent. Now the next one is pressure. Now the pressure, I believe, is in millibars, but to change it to atmospheres, you multiply by this constant of 0.009869233. So then I do a print statement of what the current barometric pressure is, and after the number I put ATM for atmospheres. Now another bit of information is what the conditions are. Now if you look at the conditions, let's scroll back up to the conditions, and it says here right now it's broken clouds. If we look down below, I print out broken clouds. And we go from the conditions to the wind speed, and I get the wind speed, and I display that as miles per hour. Now there's another bit of information that's there sometimes and sometimes it isn't. And it's called gusts. Well, we don't always have gusts of wind, and instead of saying gust is equal to the wind speed, they just don't do it. So if I try to access and it's not there, I'll get an error. So I just ignored the gusts. And then the last bit of information is what direction the wind is coming from in degrees. So I print out the wind direction in degrees. So that has the data that we want to get from what's provided by the website. And then after that's done, we go through the display. And in the display, I set on the first line where we are and what time it is, and I set up what the temperature, humidity, and barometric pressure is, and what the weather conditions are. That writes the information into the display's buffer, and then we write the buffer out to the screen. Then we zero out the buffer again, and we leave it on the screen for 15 seconds. And then we build the second screen, because I can't get everything on one screen. So again, I print the location, the date, and then the sunrise time, the sunset time, the wind speed and wind direction to the buffer. I write the buffer out to the screen with a show statement, and then I zero out the buffer again, and I sleep again for another 15 seconds. Now, over here in this screen in the upper right corner of the video, this is the first screen, what the first screen looks like on the display. And below is the second screen. So I'm sorry, I got those reversed. The bottom one is the first screen. The location, the time and the date and time, the temperature, humidity, the barometric pressure and atmospheres, and the weather conditions. Now this is what it was, not when I made the video, but when I took the picture the day before. Now up above I have the second screen where I have the location, date, and time, what the sunrise time is, what the sunset time is, what the wind speed is, and the wind direction. Now it looks like I have a problem because I can't get the H on the screen. I'm going to have to go back and do some finagling so I can get the full amount on there, because if we happen to have a value that's above 10 miles per hour, I won't even get the P on there. I'll just get M. So it looks like I need to make a little change in the program.